Hi, I'm following along with Paul McWhorter's Raspberry Pi W lessons, and we're on lesson 5, reading analog voltages. And Paul showed the math for the slope equation so you can figure out um, what uh, the slope is and how to do the conversions and everything. He went through the math and um, basically we're reading a potentiometer, and the range on that is from about 430 to 65,000 and something. And um, we were supposed to be, since we're reading the 3.3 volt rail on the Pico, we were supposed to see how much voltage we were getting at the input pin. And um, so it was between 0 and 3.3 volts. So that was our slope for this one. And Paul goes through the math of doing that and, proves out that it works by plucking the numbers in. And then for homework, he said, well, I'm going to give you homework and we're going to use the same potentiometer. So our range on that's still 430 to 65,000 and something. But he said, I want to go from when the potentiometer is all the way down, it's going to read 100. And when it's all the way up, it's going to read 0. So you're going to end up with a negative slope on that. And um, I think it might have threw a wrench in the works of what some people did. Also, Paul ended up in this area with a 0. So when he really didn't say what happens to this part of the equation. Because it's a 0, it doesn't matter, it just disappears. But if it's a negative number on this side, to get it off of this side to get down to just y, you have to add it on to that. So you'd be adding 0. So that was something I think also slipped up people, that they didn't realize what happened between this step and this step. And anyhow, I did the math on paper and pencil, so I can maybe show you what I got. So like I said, we got our 0.1 and 0.2. We're going 430 to 65, 536. And then our y was 100 to 0, a negative slope there. So we do our slope calculations, and we end up with negative 100 over that. And then we put it into our equation to figure out what our scaled output's going to be. And we do the math for that, put it all through there. And the X turns into whatever our reading is. That's what we're going to, when we do our coding on it. And then our Y is our scaled output. So let's get to the code and show you that it actually works. So let's see. So here's what it comes, our scaled reading, and here's all the numbers that we had in our thing. Got our reading here and our thing. So let me go back maybe to that photo. So on this photo here, on mine, like I said, we had the minus 100, and you can see once we do our math, and then to get the y on the one side by itself, instead of it's minus 100 here, so we're adding the 100 over there. So that's what might have slipped a few people up. But let's get back to the code, and I did the same thing in there. So our scaled reading, and I put the 100 plus on the end there. And we're just doing it, and we're sleeping in between each one. And I got my potentiometer wired up. I got it all the way on minimum now. So we'll go ahead and run it. I got the potentiometer all the way to the left. So all the way to the left is, down on the potentiometer. And then if I go all the way to the right, I get 0. And if I go somewhere about halfway in between, we get close to 50, 45. You can see, just so I got some numbers that you don't have a bunch of decimal places, I just rounded it to the whole numbers here. The scaled reading, just when I printed it out, I just rounded it. So that's cool, but my problem with this is that we're calculating all this out, and Paul did all the calculations for the 0 to 3 volts, and then he had us do all the calculations from 100 to 0. So we had to do calculations so we could put it in our code. So first, Paul says, why use constants when you can use variables? So I agree with that 100%. My thinking is, why do hand calculations when you got a perfectly good microprocessor that can do the calculation for you? So I said, so, okay, we got all this information. How can we get this boiled down into calculation that we can actually use? So I came up with this idea here. All right, so we got this is from our last one that we did. We have our 0.1 and 0.2 and everything there. And like I said, they're, X1 and Y1 and X2 and Y2 is what, what they are, X and Y. But really for what we're doing, we have a range here of our input range on the potentiometer was 430 to 65, 536. So I thought, well, we could keep track of that and we could put it in a tuple or a list. A tuple would work. And first I was going to call it input range, but I said, no, let's use our X again. So we're going to call it X, and we're going to call it a tuple. And then the same way, our output range was 100 to 0. That's Y1 and Y2. So we have 100 to 0. And I said, okay, so and we just call that Y tuple. Make it easier to keep track of what we're doing. So then we go to our slope formula here that Paul gave us, and it's actually just the Y2 minus the Y1, X2 minus the X1. But now we're in a tuple, so we have to do a little conversion. So our Y2 is actually our Y tuple position 1. Remember, they start at 0, 0, 1. So our Y2 is now position 1 in our Y tuple. So we got Y1, and of course Y1 is Y sub 0 in our tuple. Same way on the bottom, we're changing it from X2 to X sub 1 to X and minus X sub 0. So we got those taken care of. All right, so now we have our slope that's going to be calculated for us in our code if we do it right. And like I said, we're going to end up giving it our input range and our output range as a tuple. And then I'm going to put it into a function. So our function is going to use this X and Y, so we can use that. So then, we had the X and the Y that we turned into different thing, voltages, or the result I put mine as. But I just said the X is going to be the reading because we really don't want that. So we're going to have a reading. And the Y is the answer that we're going to get from our function that we make. So I'm just going to call it result, just make it reading and result. So they've changed that. So this is our formula for figuring that out that Paul gave us. So first thing we have to do is he gave us this Y1 and X1 and X and Y. So I changed those out for these and plus the positions in the tuple up here. So we have y becomes result, and then y1 becomes y sub 0. And then we still have our slope that we calculated up, that we figured out on that one. And like I said, this is a multiplication here, so times. And then the x become our reading. And then we're subtracting x1. And remember, x1 is actually x sub 0. So we did that. But then we still got to get the result on the side of the equals by itself. So again, it's a subtracting y sub 0. So we just need to add that to the other side of the equation to get rid of it. So yeah, our final thing is result equals slope times the reading minus x sub 0, and then we're adding that onto it. So that's basically these two lines of code. If we give it a reading and we give it a input range and an output range, our function should be able to figure out what it is with no more input from us. We don't have to go through and calculate on paper and pencil. So I'll show you what I came up with and show you that it's actually working. So here's our thing. And like I said, doing basically the same thing here, getting our potentiometer, our ADC thing, analog to digital converter, up and running. And then, like I said, I just made this called input range, and this is our input range. It's 430, making a variable out of a tuple out of that. And then our output range was 100 to 0. And you can see that, that works and everything. And I have this function here. We'll get back to that. But then we're doing the same thing down here. Is that we have a reading our potentiometer, and then we're actually going and doing this function, scale it, I called it, scale it function. And we're inputting our potentiometer reading that we got, and then our input range tuple and our output range tuple. And then we're just printing the rounded figure of that and sleeping 2 seconds again. So like what we in our handwritten thing down there, like I said, all we're doing is we're getting, in our scale it function is the readings coming in, the x tuple and the y tuple. And I wonder, let me see if I can bring both of it, if I can move this over so we can see what's going on. Yeah. Probably not. Probably not. So anyhow, but we can look at it and you can see we got our result equals m times reading and that. And plus we have our slope. We're doing the calculations for the slope there. So here's our calculations for the slope. You got y1 minus y sub 0, and then you're dividing that by the result of x1 minus x sub 0, and that's giving us our m. And then on the next line down, we're doing the slope times reading minus x sub 0, and then we're adding the y sub 0 to it, and then we're just returning that result. And then that's doing that, and so we can show that that's going to do the same thing when we run it. So I'm about halfway up right now on the potentiometer. I'm going all the way to minimum, and that should be 0, which it is. Going all the way, turn the potentiometer fully clockwise. Now we're down to 0. Go back in between it. So the fun thing about this is that, okay, we'll stop that. Oh, we don't want our output range to be 100 to 0. We want that to be 0 to 3.3 volts. So the only thing we have to change in our code is say 0, make a tuple to 3.3. Now we can run that again. That's all the change we made. Let's run it. Oh, I got this as a rounded, so I will need to stop that and won't round that. Well, let's see, I think I can round it to 2 places. Let's see, comma 2. Let's see if that works. And we'll run it again. Yeah, there we go. So we're going to turn it all the way counterclockwise. I thought it was supposed to be the 2 places. I was probably because it was negative. Okay, it's probably need a little absolute. So there we go. So basically we're at 0. I'm not sure why it doesn't round it at that point, but anyhow, all the way counterclockwise is basically 0. And as we go up, now we're rounding the 2 places. And we should get all the way up to the top, 3.3 volts. And the only thing we had to do is change that. So, you know, maybe if we're picking the intensity of a color or something, would it be 0 to 255? So I don't know. I'm just coming up with different things to try. So it'd be 0 to 255. And we can probably go back and make this integer again. And we can run it. And it's all the way up is 255. And all the way down when we're -1 instead of 0. So we'd have to make sure that we get down to 0. We'd have to do a little checking on our math to make sure that we don't get negative numbers on that. So we could do that easy enough by checking that. But anyhow, this is, like I said, it's good to know the math. Paul showed us how to do the math, but I think that I proved that that the math still works when you let the microcontroller or the computer do all the math for you, and all you do is put in input range, output range, and then give it a value to change up. I think that's all I want to talk about today. Anyhow, thanks, Paul, for the lesson, and I look forward to what comes next. Have a good day.